We're going to look at multiplying polynomials and how that interacts with real life sorts of problems. And one of the things that you may have been shown at an earlier age, middle school, elementary school, something like that, was just a way of organizing how you approach word problems. It's called the cubes method, where you circle numbers, you underline the question, you block in action, things that you're going to need to do, you evaluate or eliminate, mark out things you don't need. And I've always done that sort of thing, but never really solidified it to that kind of a pattern. So what I'm going to do is I'm going to look at this problem, and I'm going to kind of follow that, just marking the things that are important. You can do the same on yours, especially when you get to the homework assignment and teacher made. You can use circles, underlines, all that kind of stuff is there for your use, and it's an advantage you've got. It's a lot neater and cleaner than even if you have to write the words down and circle them. But anyway, this problem is Harry is building a fish tank that is a square prism. Now, what you need to understand about a square prism means it's kind of like a cube. It's the same length on all sides, okay? Except he wants the height. So he wants to take this cube and stretch it, it says, to be 6 inches longer. So it's going to be a little taller than the width and the length. And if he needs the volume in this fish tank to be as close as possible to 3,500 inches cubed. So what should the length of the tank be? Round to the nearest inches. And well, first of all, I'm going to circle some of the important stuff in here. For example, 6. Okay, I'm going to circle that. And I'm also going to circle 3,500 inches cubed. That's the volume I need there. So I'm going to circle that. I'm also going to look at what's the question asking? What is it that I'm supposed to be finding? Well, it says here, what should the length be of the tank? So I'm going to just underline the question. In other words, I'm wanting to find how tall, what the length of this tank should be. And really that should say what should the height of the tank be, because that's what we're asking. In order to do that, I'm going to need some things like I need to understand the concept of the volume. What does that mean? And I'm also going to need to round it to the nearest inch. That's pretty important. Is there any information you see in there that we don't need? And not really. I mean, there's not any extra information that I see. So let's talk about how we're going to go about solving this thing, okay? So we boxed in volume because volume tells us to do something. We need to remember what it tells us to do. So let's talk about what we're going to do with all this information we've got. And again, you've got it in your notes, posted there in Google Classroom as well. So when I look at this problem, the thing I look at is that I know to find volume, I have to multiply length times the width times the height. So I know that right off the bat. So the first thing I wrote down was, in order to find the volume, I've got to know this information here. I've got to multiply length times width times height. And the problem tells me that it's a cube. In other words, everything's equal. So the length and the width are actually going to be the same measurement. Okay, so I'm just going to say, well, let's let S equal the length and the width. So in my working this problem, I wrote that down. Let S equal the length and the width. Sorry for my sloppy handwriting. It just got super sloppy right there. And I know from the problem that I want this height to be 6 inches more than the length of the width. So the height's going to be S plus 6. Now, that's kind of to basically refining it down to the information I had there. Well, the first step would be to write the formula with this information I've got. So I know that length is S. I know that the width is S. And I know that the height is S plus 6. So the volume equals that. Okay? The volume equals S times S, because we know the length and width are the same, times S plus, we're going to add 6 for the height. All right, so I'm going to simplify that using what we've been talking about today and multiplying monomials and binomials. So I know that S times S is S squared. And I know that S squared times S plus 1, or excuse me, S plus 6, I can take S squared and multiply it times that binomial. So when I do that, I'll get S to the third plus 6S squared. All right, so the formula for my volume is S to the third plus 6S squared. Remember, I want this volume to be as close as I can get it to 3,500 inches cubed. So here's what I'm going to do. I'm going to start out with some values for S and create just a bit of a chart. And then find out, well, what is the volume then for those values. So I want to start with, let's let S be 14. Let's see. It's kind of a shot in the dark here. I'm just seeing what's going to happen. What's my volume going to look like when S is 14? To do this is simply using my handy-dandy graphing calculator. And that's what I would do if I were you, because the math here is a bit sticky, I guess you might say. So you call that up right quick. Here we go. So I'm going to put in 14 raised to the third power plus 6 times S squared. Okay, so that's what I'm going to put in my calculator. So I'm putting in 14, up arrow, just like the teacher may does, to the third power, plus 6 parentheses, just like I wrote it down. And then I'm going to put 14, and I want to square that one. Close my parentheses so it'll multiply. I'll hit enter, and that'll tell me it's 3,920. Well, that's a little too big for the volume, isn't it? Remember, I wanted my volume to be 3,500. So what do? Well, I try a little smaller number. I try 13. Do the same thing, 13 to the third power plus 6 times parentheses 13 to the second power. And hit enter there, I get 3,000. 211. And I can try other numbers, but I have, I found that the 13 will give me 3,211, 14 gives me too much. So the number I'm looking for then has to be 3,211. That's the closest to 2,500. So the length should be equal to 13. The width should be equal to 13. And the height should be equal to 13 plus 6, or 19. And that will give me a volume of 3,211. All right. Any questions on that? So that's what it's going to look like as a direct application.